Good afternoon. You're on Likeable Science here. I'm your host, Ethan Allen, broadcasting here from ThinkTech Studios in Pioneer Plaza. Likeable Science is all about having fun with science, finding out that science is really an enjoyable, active, dynamic, and interesting part of your life, and nothing to be scared about, you know? So to help me explore a piece of that today, I have with me Robert Olivier from Prota Culture LLC. Welcome, Robert.
Hey, thank you, Jay, for having me. Yeah, what we're basically doing is we're doing more than just science. We're farming insects.
Yes, that's what I was going to say. We're going to talk a great new trend here, farming insects. Some will inappropriately call it grub composting, but that's that's not exactly really what it's all about, because it's not truly a composting issue. It's a bioconversion, as you referred to it earlier, I believe, where you're taking food waste and converting them into essentially other animal proteins, fats, and all for further use down the food chain or up the food chain, either way. Excellent. So you've developed a device called a BioPod, and that basically uses some grubs, some little larvae, to eat the food waste, and then they essentially remove themselves from the mix as they mature and separate themselves out. So you have both this residue, whatever they leave behind, but you also have these pupa then that you can go off and do other things with, freeze, crush for biodiesel or animal feed or any kind of thing, right?
Yeah, absolutely. So what we've done is we created a small insect farm for your backyard, and we did this about 6 years ago. So this is what got us going, and so now we're the biggest producer in the United States from insect farming equipment. However, what we've basically done is we created a beehive for another beneficial insect called the black soldier fly. And this species has an amazing ability to eat a high amount of organics. Organics are everything. Unlike earthworm, we can also handle meats, we can handle dairy, fruits and vegetables. What we don't really handle is grass clippings and leaves. There's other organisms that are suited for that. However, the bioconversions process, as you pointed out, is regulated by the insects for the insects. And what they do is they actually create a lot more insects. And so as the insects mature, they actually want to harvest out. So our beehive technology for this particular insect, in a way, allows them to be harvested out in either a bucket, or you can put it directly inside your chicken coop. And every time that an insect is ready to leave the colony, because they want to pupate, which is the next phase of their life cycle, they become lunch or dinner for your chickens. And it's kind of a concept that most people now are estranged to, but there is nothing more natural for a chicken to eat than actually an insect. Right. It is what their natural diet was. If you, there was a few scientists back in the 1970s that went to the northern parts of India, and the red fowl is the ancestor of the modern chicken, and they were able to study this species in its native habitat, and they also dissected the insect, analyzed stomach content, and 50% of the chicken's diet is insects. Could be termites, could be little larvae or grubs. And when you look at chickens, what do they like? If they're free range, unlike a lot of factory farmed insects, you'll notice immediately the free range chickens go everywhere. And one of the interesting aspects of what brought me to Hawaii was the fact that the poultry industry was dying, and the University of Hawaii wanted me to do workshops to come teach how you could farm insects to feed to your chickens as a supplement to lower your feed cost. But I was really surprised that a few days after my workshop, I landed on the island of Kauai, and anyone who's been to Kauai knows that the island is absolutely populated by chickens. And that's when something clicked inside my head, and I said, wow, modern chicken farming is going broke, yet these islands are perfectly capable of sustaining large poultry populations. What's wrong in this picture? And the answer is, there is no human-made animal feed mill that makes an insect-based chicken feed. And so a few months later, and conversations with the dean at the University of Hawaii, and we said we have to make an insect-based animal feed. And the USDA agreed, and they sponsored me on a grant to do some more research. And we have poultry trials now going on at the Haleakala Ranch up in Maui, because they have the largest poultry population anywhere in the state. Everybody else pretty much has closed their doors. And that's why eggs are from the cheapest of $4 all the way to $6, $7 a dozen for organic and locally grown. So there's a real need to solve this ecological and economic deficiency.
And again, this BioPod device, you've got it in several different forms or different scales, as it were, right? So you can do a smaller home unit or a larger commercial unit, right?
Yeah, and one of our prototypes, as you see on our slides that we have, we've been looking at what's the productivity per acre, and typically what we see is that an acre of soy and corn are some of our most productive systems, and typically our livestock per pound of protein produced are our most inefficient producers. And this is the great argument why a lot of people are vegetarian, is in order to eat or meats or even eggs or drink milk, it takes a huge amount of soy and corn. However, when we farm insects, we've noticed that instead than working on a per acre scale, we can work in just a simple, larger BioPod system. Our last prototype was able to produce 414 pounds of protein per acre, while 414 pounds per BioPod, sorry, while an acre of soy only produces 356. So we have more protein bioconversion in one unit than you have in an entire acre of soy. But there's a big difference. Unlike that acre of soy, we used no fertilizer, we used no herbicides, no pesticides, definitely no insecticides, and also no antibiotics. And we didn't need an acre, we only needed a few square feet, and we didn't need to irrigate. Okay, that sounds like magic, right?
Well, but plus, you got rid of a bunch of waste.
That's right. So we get rid of about 7.5 tons of food waste, all within 20 square feet. And so when you look at an ecosystem like Hawaii, does it make economic sense to rely on large acreages that need large amounts of fertilizers and chemicals to grow your own animal feed? No, it doesn't. So what happens is we import the feed. And then when the price of oil keeps going up, we stop importing the feed and we only import the eggs. And that's what happened to the poultry industry in Hawaii. And that's why it's gone in the last 20 years. So basically, a lot of people have this feeling of what is insect farming really like. And I have a wonderful time lapse here. Excellent. And this time lapse really can show the essence of what's going on in insect farming. Now, you think this is composting or decomposition. It really is not. If you look on the bottom right, there's a timer there, and that's not days, that's hours and minutes. So we're about not even 3 hours into this bioconversion process, not decomposition. And what you're noticing is that the insects are able to eat any type of organic matter, just like pigs would. There's one big difference. Unlike pigs, insects don't create manure. And so we are not having to deal with a wastewater or odor issue at the end of the day. A lot of people say, well, wait, composting smells. What happens here in your situation? Because things are eaten so fast, you throw in spaghetti sauce, it smells like spaghetti sauce until the spaghetti sauce is eaten. We actually generate very little compost in this system. We're a half a day into it, and you can almost tell there's almost not anything left. And so these insects are constantly looking, and now they're eating the harder to digestible materials. But the biggest thing is that there's other processes that people can use to get rid of waste. There's anaerobic digestion, there's composting. What's the main difference here is that when at the end of the day we are able to harvest the insect, a lot of the fats that were in our organics or sugars or carbohydrates end up being insect fats. A lot of the complex proteins that ended up being in our organics now end up being simplified insect proteins. And this means that a lot of the nutrition is not lost. You remember I showed you that slide saying it takes so many acres to maintain just a few livestock. What if it doesn't take that many acres of soy and corn to maintain that livestock? What if we can do that just from our waste? And so that really changes the paradigm, because when we look at an effective chicken in the wild, chickens don't have entire territories devoted to themselves in order to sustain them. They're able to integrate within an active ecosystem. And so in that regard, what we're doing on an industrial scale is maintaining that ecosystem so that we can actually have a society that generates very little food waste and at the same time proportionally have a vibrant livestock industry. For Hawaii, that's almost $60 million a year of egg production that you would be bringing back, 800 farmer-related jobs. And on the waste management side, it's probably about $50 million of landfill that we avoid. So there is truly an economic incentive in Hawaii.
Right.
The mainland, that's a different story.
Right, but here for Hawaii, this is peculiarly well suited because too we have a huge tourism industry. We have huge numbers of hotels, restaurants that are producing gobs and gobs of food waste every day. Basically, it has to be either buried in our landfills or shipped, in some island, shipped off the island.
Yes.
And instead, you can just,
for example, the Four Seasons in Lanai has to barge their food waste off. That means that they have to have an expensive transportation on a daily basis. The Four Seasons in Lanai also don't want to create a massive landfill on their island. They want to keep the island pristine. So this comes at a high cost to them. By being able to solve the organics on site that day also allows them to actually recycle more.
Right.
And once they're able to recycle, that means that now the barge doesn't have to come every day. They can have less frequent intervals. And so that is a huge logistical savings,
right.
And not just an environmental one. But also, it's not just the resorts and the buffets that have a lot of uneaten food waste. We've been working with Pearl City High School for over a year, and we actually were able to teach the special ed kids how to become insect farmers. And we learned a lot from that process on how actually to make our bins more resilient to human error. But also what was quite amazing is that the special ed program diverted a tremendous amount of tons from what would be going to food waste. And specifically almost over 30 tons in a year. There was days when we were picking up 500 pounds of food waste. And it's because the kids didn't eat it. And so from a society perspective, we've got federal mandates that pay for these school lunches. But sometimes they actually pay more just in the waste haulers here in Hawaii to get rid of it. And there's a real opportunity to look at these massive point sources of organic waste. And it's clean material.
Right.
And it's not being composted, it's not being overrun by bacteria. It's as safe as feeding a pig cafeteria waste. And once you can change your mindset about that, you start realizing that insects are not just something to be eradicated, but the right insects under the right conditions with the right tools can be propagated, and they can actually serve a societal and economic purpose.
I mean, just right back to the honeybees that you mentioned earlier, right?
That's right.
Those have been around and are cultivated and very purposely propagated. Indeed, there's huge crises right now because the hives are dying out and there's all kinds of...
And the value of honeybees is not just the value of the honey.
Right, right.
It's the ecological value as pollinators and that. So this specific insect, the black soldier fly, what makes it very, very, very unique is that it has the ability to do a waste service, an ecological waste service. They're a decomposer, and that's what's really important. And so when we look at this species from a life cycle perspective, I have this on the slideshow, what you're seeing, what's really unique is if you look at the small letters, the flying adult, which is how most people identify a fly species, is actually the least pronounced in this species. It only lives about 5 to 8 days. Yet the grub or the larva that eats food waste, which is what this species is very, very well adapted to, can actually last almost up to 6 to 8 weeks under stressful conditions, and under optimal conditions 2 weeks. So its main life cycle stage is actually where it eats a lot. Wait a second. It only has one life cycle stage that eats? Yes, it does. It only eats in the larva stage. The flying adult for this species, unlike house flies and fruit flies and blowflies and pest flies, all those flies eat when they're flying adults. This species has very limited digestion capability because it has an incredible stomach that is well adapted to eating all kinds of organics, that when it's ready to leave those organics, it actually leaves part of its stomach behind and tries to clean itself and has natural antibiotics. So when we did tests for pathogens like Salmonella and E. coli, because those are main food safety concerns, we actually see that the organisms not only lower the amounts of pathogens within the feedstock, they reduce the smell of the feedstock, they also clean themselves when they migrate. And that is a truly unique ability of this species.
Well, this is great. We're going to have to take a small break here, but we're going to come right back and continue this conversation. You're watching Likeable Science with my guest Robert Olivier. We're talking about insect farming and all the benefits of this wonderful process. We'll be right back.
Aloha, this is Keli'i Akina. It's my privilege to be the host of Ehana Kako, a weekly program on the ThinkTech Hawaii Broadcast Network. Ehana Kako, what does that mean? Well, many people have heard of Epule Kako, let's pray together. Ehana Kako means let's work together. Let's work together to build a better economy, government, and society. And every week, Monday, from 2 to 3 o'clock, you will see movers and shakers and other people who are working together to build a better economy, government, and society. Again, I'm Keli'i Akina on the Ehana Kako weekly program on the ThinkTech Hawaii Broadcast Network. Aloha. See you here Mondays 2 to 3.
And you're back on Likeable Science. I'm your host, Ethan Allen. With me today in the ThinkTech studios is Robert Olivier of Prota Culture. We're talking about insect farming. Now, we've talked a couple of times now about this BioPod device. Maybe we can see a quick picture of a BioPod device in service, as it were.
Well, this is my favorite picture. It's by one of our clients that was actually sent to us. Not only is it a BioPod, it's actually a full home egg production facility. What happens is people can throw their kitchen scraps into the BioPod,
which is that little gray.
Is the gray one on the bottom left. And then what happens, if you look close enough, you see a small ramp. So really what is a BioPod? It's a composter with a ramp that allows our beneficial insects to migrate out. And then once the beneficial insect is ready to migrate out, which means that they're ready to pupate, at this point, they're full of proteins and fats. And they go into a little feeding tray for the chickens. So immediately your food waste went into insect mass. The insect mass drops out into your chicken coop. And then once the chickens are ready, they go upstairs and they brood, in this example, and lay an egg. So you're actually going from food waste to egg all in your backyard. And so that's why I love this customer's picture that he sent us, because that is really the essence of why we do this.
Yeah, it's this beautiful sort of complete cycling or recycling of complex molecules, you know, so they do an amazing job.
Well, we at Prota Culture, we didn't design this insect. We didn't genetically modify it. We didn't do anything that was unnatural in any place. All we did is just provide a habitat, not for the insect's sake, but we actually provided a way for man to interact safely with the insect. At the time, I was with someone and she was like, "What are you designing this for?" And I had engineered it well, and then I realized that certain people have the ick factor. So I realized then, well, maybe I need to put a second lid on it or something so people don't have to look inside. These are not insect requirements. These are more part of, I think, the human aspect of industrial design.
Sure.
And so those are some of the aspects that we're working with. Also now on our team member, we're going to get a world-famous insect designer that's coming in. Her name is Katharina Unger. So I'm really excited in the next couple of months to be designing the next generation of BioPods with her.
Cool. Yeah, but it's very much like sort of the honey, the beehive, right, which is just a device. The bees don't need it, but it allows us to interact smoothly with them and get the desired product, the honey in this case, out in a simple way, and yet keep the productivity of the bees up, basically. So, yeah, that's great. So you showed us sort of a backyard version. That's sort of your small scale, right? You also have a larger version of the same thing, right, that you can do for bigger.
Yes, and those are the challenges, is doing this on a larger scale. So the backyard versions actually depend on the native black soldier fly to come lay their eggs in the units.
Okay.
The large scale versions, we actually have to take about 1 or 2% of what we harvest to go into a mating cycle, and we call this the parent colony. And the parent colony, all they're used for is laying eggs, and those eggs are then harvested and go into larger biopods. Some of the unique factors of our company is that a lot of insect rearing, not just black soldier fly, but most, are done in trays, and there's a reason for that, is because a lot of organics that the insects need in order to feed themselves become unedible after a while. And so we've now created a new unit that we can homeostatically control all the parameters so that various feedstocks can come in, and it's always to the optimal settings of the insect, not to other bacteria that want to start or create a compost cycle, which is called a thermophilic bacteria. They want to heat up the entire system, and then once you start thermophilic composting, and it's hard to stop that process. So we keep everything in control with some few, a few sensors and a few feedback loops. And the reason that we're doing that is so that we can actually make it foolproof. Especially having worked with the special ed kids, the need to not have to teach everyone how to do this, but the need to be able to control this in a commercial setting, very dependable, is probably the next frontier in this technology. And we're very clever humans in creating amazing tools. And for us, the next aspect is to really fine-tune that process, because it's my goal as a company not to create the next best waste dumpster. No, the goal is to bring insect farming, specifically urban insect farming, back. Because where in our society do we have the highest concentration of food waste? Actually, it's in our cities.
Right.
And if we can give a whole team of urban insect farmers the tools necessary, they can really bring productivity back into the cities. Specifically in Hawaii, where agricultural land is very scarce. But, like you said, you've got tons of resorts, you've got tons. You're really in an insect farming mecca, because you're not competing with traditional soy and corn that has a highly subsidized product to compete with. So in that sense, the notion that an urban insect farmer can either come pick up your food waste or have you control a colony within an insect farm is very different. And I also think personally that the restaurant that has a dumpster, they treat it as a dumpster. They throw everything in there, and then it's a mess once you receive the material. But if they truly see this as a beehive, then they treat it as an ecosystem and as an organism, and they respect it more. So design is very important in the next generation of prototypes. And I think design also, from a society perspective, when people know that this is safe, it's sterile. The hardest problems we have in designing our units is actually keeping critters out, like rats or mongoose. It's not the fear that everyone has is, are these insects going to get loose? No, absolutely not. They're inside because they want to be inside.
Right, it's great conditions for them, but indeed, that's a high protein source for, yes,
that's
your
right.
Rats understand that, and they want
That's
to
right.
get in
So
there. And
our biggest challenges from a design perspective are not the insects. It's, again, the human factors, the real disease vectors like rats. That's exactly what we do.
But again, so these systems, you could have, say plastic wrap that had been around food gets tossed in there, and basically it ends up being sort of cleaned by these insects then.
That's right.
And you could pull, periodically, you just have to go through and pull that stuff out, and it's relatively sort of cleaned up for you.
It is, and if you do it on site, if people really choose to pollute it, it's still theirs. We're just maintaining the insect colony. So we're doing the entomology part, and we have readings on all of our bins, and it's up to the owner of the waste to really decide how much he can do. But the wonderful aspect, though, is that once you get rid of the organics responsibly, that saves the owner of the restaurant a lot of money.
Right.
Because it's the organics that require a restaurant to pick up, once a day or every 2 days, because wait much longer and you've got a stinky dumpster behind your restaurant. However, if the organics can be managed correctly by you or by your staff, out of sight, and they're just serviced by our insect farmers maybe once every 3 days, then what happens, especially with a restaurant gets a lot of organics and a lot of packaging. That's what comes in. So immediately restaurants can then take the organics, and that goes towards the BioPod system, and the packaging goes towards recycling, and we've just created a zero waste restaurant. And so from a dollar perspective, it is very beneficial for the restaurant owner, especially in Hawaii, where you pay hundreds of dollars per ton, and specifically, you know, over $1,000 a month to come pick up all your dumpsters. And so in that sense, we are not only we don't really have to appeal to people's higher senses. You can immediately affect their pocket, and so the adoption rates are much higher.
Well, no, this is wonderful. And so for these colonies then essentially become reasonably self-sustaining, or do you need to constantly reinfuse new larvae?
The home units are very self-sustaining because you can work with the natural populations. However, in colder climates, winter comes and these do get limited. When it comes to the commercial units, because of the fact that you have commercial customers, and commercial customers need dependability, it is just good practice to absolutely have little starter colonies on hand. And it's one of the things that if you can artificially up the amount of grubs that are in a colony, it takes a lot of the risk away of something happening that's non-desirable. And what do I mean by that? Overloading in food waste, or them not being able to eat something quick enough, or anything like that. And they actually can stabilize a lot of their environment just by themselves. So you need enough of them. And by artificially having them available, we're creating right now a mating chamber that can create about 20 million eggs a day. 20 million eggs, once fully grown, is about 4 tons of larvae, which means that we can sustain about 10 chicken farms. And we would have to service multiple restaurants. So by us being able to provide the entomology, it takes all the complexity out for the kitchen staff. And in that sense, it's kind of like a porta potty model without the chemicals. Is you hire us to maintain the entomology, we come deliver all the services on site, and no longer are we hauling any type of waste from one side of the island to the next. No longer are you doing it on a daily basis, and also your recycling rates go up. So for a restaurant, there's a beneficial impact with this type of waste service versus traditionally even going to an anaerobic digester that just makes methane.
Yeah, I can sort of see this again. It's a win-win all around here for everyone, and cleans up our environment, gives us a lower sort of impact on this, on our using less of the limited resources on the island here. So that sounds wonderful. So I want to get into a bit of sort of how you got started on this, but I think we probably should actually take our next break before we do that, because I suspect there's some good stories that you've got about how you got started here. So I'm your host, Ethan Allen, and you're here on Likeable Science with us. I'm Robert Olivier from Prota Culture is my guest today, and our conversation on insect farming. We'll take a little break, and then we'll be right back.
My name is Alice Lee Hagan. I host the ThinkTech Hawaii BizEd Spotlight. We talk about fascinating people and interesting issues that affect our island state here in Hawaii. We broadcast every Thursday from 3 o'clock in the afternoon to 4, and on Olelo 54. Make sure you tune in, and we'll see you soon. Aloha.
Aloha. My name is David Day. I host ThinkTech Asia, and we talk about international business, foreign policy, geopolitics, and we broadcast live every Thursday afternoon at 4 o'clock and on Olelo 54. Make sure you tune in, and we'll see you there.
Hi, my name is Seymour Kazimirski. Welcome to Seymour's World. We're here to open minds and facilitate conversations. Our topics range from human interest stories to political stories to around the world stories. I hope you enjoy our show. It's on ThinkTech Hawaii. Thank you.
And you're back with us on Likeable Science here on ThinkTech Hawaii. We're broadcasting from the ThinkTech studios in Pioneer Plaza. I'm your host, Ethan Allen. With me today is Robert Olivier from Prota Culture. We've been talking about insect farming, and I'm learning a ton of stuff that I never knew before about the really amazing efficiencies of this process and how it's particularly well suited here for Hawaii. But I want to step a little bit back, and it's such an intriguing business. I wonder sort of how you got started in it. How did this all come about?
Well, I think all innovation starts always with an argument. And this particular argument was between my dad and my aunt, which was his sister. So it was a brother-sister argument. At the time, we were working with various recycling technologies for a project in Texas, and we were visiting my dad's sister in Louisiana. And my dad was researching anaerobic digestion, static pile aerated composting, all of these big engineering terms.
But he was recycling something else, right?
Yeah, he was recycling metals,
right.
But he had to get somehow rid of the food waste so that his recycling rates could go up. And so he was looking at this food waste equation. He was reading all the engineering manuals, and he's just perplexed and didn't really see a solution. And his sister kind of goes to him and says, well, why are you reading all these manuals? You can just compost it. And he goes, no, the residence time of the composting, the infrastructure needed, it takes too long to break down. And he gave her every engineerable excuse possible. And she says, no, that's not true. When I throw something in my compost pile, it's gone the next day. My dad didn't believe her. And so they threw something in the compost pile, came back, was gone the next day. So immediately my dad accused the local raccoon from getting in a compost pile in there. So they redid the experiment, secured the bin with wire, and he came back the next day, and guess what? Everything was gone. So at this point my dad said, okay, it's not a raccoon, what is going on? And basically he started probing into the compost pile, and 2 inches deep down there's this active colony of insects eating away everything. So immediately my dad said, well, see, I'm right. This is not composting. These insects are the culprits of why everything is gone. Well, his sister basically looked at him and said, what are you talking about? I'm right. I've been telling you this over and over. But it actually started as a brother-sister argument that then immediately, just to kind of give you an idea of what sets us apart as a company, is we immediately took this species and we sent it to Texas A&M and told Texas A&M, hey, entomology guys, can you tell us who this is? What are we working with here? And by the way, send us all the scientific literature you can. So a few dollars later, and about a week later, we get an invoice from Texas A&M and we get the answer. And basically what it said was, this species called Hermetia iliscens, commonly known as the black soldier fly, non-pest species. And then we were like, okay, what about the scientific literature? We got 2 papers eventually, and these papers were basically efficacy studies on common larvicides and insecticides on how to kill them. And at that point we really realized that we had a tremendous challenge in trying to figure out what we could do from an entomological perspective, because there was so little knowledge about how to use insects. And there was a ton of knowledge on how to eradicate them. And so initially we realized that we couldn't sponsor the research, but we kept talking to various entomologists worldwide, and a lot of light bulbs have gone up in the last decade. And now there is a real movement towards insect farming. Particularly we're focused on farming insects for animal feed because chickens eat insects, for example. But now there's a lot of academics looking at the possibilities of using insects also to feed humans. Mm-hmm. And one of the unique aspects about that, and from a science perspective, is that insects are not warm-blooded. So even if you feed the insects soy and corn, they're much more efficient at making a pound of meat than a cow or a chicken, because they can keep their body temperature very, very low, And so when it comes to bioconversion, they're very efficient.
Right.
And when we look at animal feed, you can say, well, we don't have to give him all the good food. We can give him our off-grade food. And that's when I think the real efficiencies start coming in. So not only are they metabolically better suited for bioconversion, they can also handle stuff that nobody else would touch organically. And so it is my belief and it's my experience that in order to have a resilient agriculture, not just measured in pounds per acre, but truly agriculture that works as a dynamic ecosystem, you need three components like any other ecosystem. You need an animal, you need a plant, and you need a decomposer. Insects are the decomposer that can support part of your livestock. The livestock then its manures can still go fertilize the fields. And so from a Hawaiian perspective, the livestock is the most crucial one that we cannot affordably maintain in Hawaii unless you have a species that eats insect in the wild like the chickens on Kauai. But when it comes to industrial scale, we need an industrial decomposer. Once we get an industrial decomposer, we can bring livestock back. Once you bring livestock back, you can fertilize or compost fields in a natural way. Once that happens, we don't need the fertilizers and the herbicides and the pesticides. And so especially in a climate like Hawaii that has year-round optimal growing conditions, livestock can play an integral role. And that's how it was pre-missionary too. The pig culturally is very significant. And the pig actually has a role as both a decomposer and as both a fertilizer. And so again, we can work in that symbiotic relationship. And I think a lot of the 21st century agriculture is going to go back to those ecological principles.
Yeah, this is a beautiful cycle that you're talking about, and making it very very highly efficient. And as you say, it's one of the big differences because you're using an insect in this, that is for all of us mammals. About 80% of the calories we consume go simply to keeping our body temperatures up, and that's essentially all stuff that's then sort of taken out of the food cycle, as it were. But the insects can do that bioconversion at a much, without worrying about that.
That's correct.
And yeah, so it's a wonderful advantage to using them. For then they can become the grubs. The larvae then can be frozen, pulverized, and turned into pig food or chicken food or fish food, or so it could be used in a whole variety of things. The renaissance of the Hawaiian fish ponds here could obviously benefit from this kind of.
Yeah, and the fish pond is a great example. Will the fish pond feed all of Hawaii? Probably not, but they will make an impact on the community surrounding these fish ponds. And same thing, the island of Oahu has so much food waste that there's not enough pigs on the island to support the amount of food waste being generated on these islands. So by getting the insects back in there, we've made projections with Prota Culture that if we took 1/3 of the food waste on Oahu, that we could take 50,000 tons away from the incinerator every year, which has about a $10 million economic impact that goes from the tax dollars. We could, at the same time, produce about 300,000 gallons of biodiesel. Wait. Biodiesel? Absolutely. One of the reasons is that insects are also high in insect fat, and feed pellets have to be low in fat. So we actually press the fat away from the protein when making an insect feed pellet. And that biodiesel that can then be used for us as a company perspective to power our own trucks to go pick up your food waste, or to power our insect farmers to go from address to address, and also to run the feed mill, because the feed mill needs electricity, so we can use our biodiesel to run a heat power genset. The power will obviously power the equipment, and the heat will actually dry the insects before they're being processed to become a feed pellet. So unlike traditional pig farming, where the pig farmer has to buy fossil fuel diesel to go pick up the food waste, Then he's got to cook the slop, which requires a lot of energy. Then once the slop is cooked, he's able to feed that to the pig, and where the pig makes a lot of manure. This insect farming model is we create our own biodiesel. The food waste gets bioconverted, creating only a finished compost. And then the pressed insects create a feed product that can go back. And we're only having to dry that little bit of insect at the end. So we didn't dry all the slop or do anything that was highly... we couldn't create enough biodiesel if we had to dehydrate all the food waste that we received. But because all we're doing is just drying the valuable material at the end, we're very efficient.
Yeah.
And so we do believe that even with all the amount of biodiesel that we'll be consuming, we're still recovering 20%, 3 times more energy than we can consume ourselves. And here's the most amazing part, is where is this energy coming from? Well, it's coming from the fact that American diets are laden with sugar, fat, and simple carbohydrates. And that's exactly what our insects want to eat. And they will take those, just like us, and create fat. And so instead than us humans becoming fat, we allow our insects to become fat, and nothing goes to landfill.
That's right. You can see obesity for insects. We can see
Absolutely.
As a
big
chronic.
fan of obese insects. That means that they're happy insects too.
Yeah.
Yes.
And yet these grubs are also pretty resilient, right? If your waste stream gets interrupted for a day or something,
that's right.
They don't drop dead immediately. They just sort of...
They keep eating the less digestible. So,
right.
For example, at our pilot that we did at Pearl City High School with the special ed kids, well, we were only receiving food waste on every school day.
On the weekends.
And on the weekends, the grubs kept eating what was harder to get to, and then on Mondays we came back. So fall break we had some issues because that was too long of a period, and we actually had to feed them from other sources. But again, that's a service that our insect farmers can
right.
help with. And our insect bins are actually mobile. You know, and so because of the fact that they can eat so much food waste in a very, very small space, it's a completely different way of thinking about waste management.
Exactly. Yeah.
It really is insect farming, and it really is a beehive structure more than anything, and so we have to approach it that way also.
Right. What we refer to as waste is actually the key valuable starting material.
That's right.
In the whole process.
That's right, because if we didn't have the waste, we'd be, you know, fertilizing fields and feeding antibiotics to just maintain our livestock. And we're not using any antibiotics, we're not using any fertilizer, no herbicides, no pesticides, no insecticides. So it's truly a paradigm shift. But here's the funny part. It's an ecological paradigm shift that already exists for thousands and thousands of years. We really didn't invent anything.
And so, sort of spinning off of this for just a moment, if you might be able to look around and find a different insect species to deal, you commented earlier, these aren't good for dealing with grass clippings and leafy matter and all.
Yes.
But you, in theory, probably somewhere in the world of insects, because there's so many insects,
That's
you
right.
probably can find some larval form that will love the leafy stuff, and you can do the same kind of parallel process to deal with sort of larger scale agricultural waste.
That's right. It might not be as simple as the species that we're working with, because all we needed was a good compost pile with a ramp. But yeah, there's no reason that we can't harness the amazing ability of termites to eat lignin and woody materials or anything of that nature. And that it's with insects, the power of the insect is partially in its biology, metabolically, but the real power is in numbers. And the most amazing thing with most of the insects is that, you know, one female can create 1,000 offspring or 10,000 offspring. And so you can really channel that infestation for good. So in the Bible we talk about, you know, the plagues and the locusts, and we're, as humans, we're powerless against it. And really what we're doing here is taking that power of infestation and also making our waste powerless against it. There is nothing that can stop these insects from devouring whatever you throw in there. And that's the beauty of the system. It's metabolics through numbers.
Yeah, that's lovely stuff, lovely stuff. This has been very exciting to talk with you. I feel like I've learned a lot, and I hope our audience here has learned a lot too. This is truly, I think, likable science, and that's what I try to do each week on the show here. Thank you so much, Robert. It's been a real pleasure having you here on Likeable Science with me. Robert Olivier from Prota Culture. I'm your host, Ethan Allen, here on Likeable Science. We look forward to seeing you all again next week.